Before we can have a look at the cells, we're going to have to first look at the electrochemical reactions. These electrochemical reactions are the same as the redox reactions that you have learned, and you will have to know that very thoroughly for this section. Let's just have a little recap at the redox reactions. We have two reactions over here, one being the reduction and the other one being the oxidation. Please remember the acronym OIL-RIG, which will help you identify which reaction is which. So the copper reaction is going to be the reduction because it is gaining electrons, and the zinc will then be oxidation because it is losing. This leads us to this overall reaction. Now what's important to understand is that these reactions are important because this is what's actually happening in our cell and in our battery. As you will see later, for this to be a spontaneous reaction, we will need two different containers with different solutions. That would be, for example, the one on the left-hand side of the cell would then contain those two compounds, where the other one would then have these two compounds in the solution. Excuse the bad drawing, but it would look something like this, where these compounds will be in this solution and that compound will be in that solution. The solids are accounted for by these yellow anodes and cathodes. That is what they are called. This is where the contact with the solid and the solution is being made. These are the electrodes. And also what you'll notice is this green thing over here. This is known as the salt bridge. The reason why you add it is to complete the circuit so that the electrons can actually flow around in the redox reactions. I'll get into more detail about this later on when we look at galvanic cells, but for now, this is all that I was trying to say. What you'll also notice is for some of these reactions, they will be very exothermic, and what that means is that they release a large amount of energy. This led to the study to wonder whether this energy could be converted into electrical energy, and essentially that is what's happening in these redox reactions, because due to the electron movement that is happening from one cathode to the other, from one electrode to the other, essentially you're generating electrical energy based off of a chemical reaction. This, however, can be both ways, meaning that the reaction can generate electrical energy, but if we supply electrical energy, we can then cause a chemical reaction to occur. This is necessary because some reactions cannot occur without any additional energy, and they need to be in electrical form in order for this reaction to occur. This interaction between chemical energy and electrical energy is what is known as electrochemical reactions. So essentially, electrochemical reactions involve a transfer of electrons, and also there is a conversion of energy that happens with these reactions, and that is from either chemical energy to electrical or electrical to chemical. And finally, an electrochemical cell is simply a device where these electrochemical reactions can take place. The two most common cells we are going to look at is galvanic and electrolytic. But before we get into depth about these two cells, we are going to first have to look at a few definitions. An electrode is an electrical conductor that connects electrochemical species from the solution to the external circuit. What you'll also notice is that the electrodes are normally the solids that you find in the redox reactions. There is also two types of electrodes you can get. You can get a cathode and an anode. To differentiate between which electrode is the anode and the anode is where oxidation takes place, and it's in the oxidation half cell, and the cathode is in the reduction half cell. An easy way to remember this is sort of like it's a sentence. So you have an ox that carries something around, but the cat is going to be red. So essentially you have an ox and a red cat. This, along with the acronym OIL-RIG, should help you easily identify which electrode is the anode and the cathode. For those that are unfamiliar with this acronym, OIL-RIG stands for oxidation is loss and reduction is gain. The next definition we're going to look at is an electrolyte. An electrolyte is a solution containing free ions and acts as a conductor. Free ions involve anything with a positive charge and acts as a monoatomic molecule, meaning there's only one atom. For example, sodium with a positive charge copper with 2 positive charges, and hydrogen with 1 positive charge. With these ions present in the solution can then conduct electricity, and that is why water actually conducts electricity very well, because of all the different ions that it has. The water I was referring to was not distilled water, so it is sort of just normal tap water that contains certain ions that are used to clean the water. Also, if you dissolve salt into water, the salt then becomes ions, and then it becomes a good electrolyte. But the next definition we're going to look at is the salt bridge, and that was the green thing that I drew on the sketch at the beginning of the video. And the salt bridge is basically a material that contains an electrolytic solution, and it connects the two half cells to one another. It also maintains electrical neutrality. This is one of the benefits for a salt bridge. It maintains the electrical neutrality in the half cell solutions. To explain what that last little bit meant about the electrical neutrality, I'm going to try and explain it with this diagram. So this red thing is now going to be my salt bridge, and the black is going to be the electrode. And essentially what is going on here is as the reaction occurs, we are going to get a large number of positive ions that are going to be forming through the redox reaction. What the salt bridge then does, it provides the opposite charged molecule. It's a sort of, for example, you would use a solution like KCl. Reason being because they can then dissociate into K positive and Cl negative ions. And what the salt bridge then does is it distributes one of these molecules into one of the solutions so that the net charge in the solution is going to be 0. The reason why it would be 0 is because you'll try and get the equal number of charges for the negative and positives in the solution. So for four Na pluses, we are going to need then 4 Cl negatives so that the solution is then neutral and it doesn't become a very positive charged solution. The reason for this is because it then hinders the performance of the battery and can sort of form electrical layers throughout the solution. It's not important to know that, but it is very interesting if you want to look further into it. This is one of the key roles of the salt bridge, to provide these ions so that the solution can remain neutral. This concludes the general knowledge of these cells, and in the next video we're going to have a look at the galvanic cell.